So let's start. Okay. Okay, so good afternoon, everybody. So let me just quickly explain what we did so far and what we are gonna do today. So what we did so far, guys, I told you if you wanna build a condition, something like that, if A is equal to 2, the way you have to do it, you have to use 2 instructions. One, you have to use compare instruction to do subtraction to set the flags. This is number one. Next one should be one of the branch instruction. Okay, that's what I told you. And then I explained different instruction for compare and different instruction for branch. Okay, so here I explained different instruction we have for branch. And then I explained how can we use compare and branch instruction in order to make some of the very common statements in any programming language. Like, for example, if statement, also if else statement, and condition like this one, if else if, switch case, and so on. So, and then last time I started to explain loops. As you know, we have 2 types of loops. We have for and we have while. Okay. And then what I explained to while loops last time. Also, I explained that if you want to create while loops, something like that, and that's what we are going to do in the coming lab. Yeah.
What about do while loops?
For loops?
Do while loops.
Yeah, it's the same thing. You can also do it using compare and branch instruction. That's a good thing. Let me do it here. For example, guys, I want to do something like that. While a does not equal 0. Is that okay? So that's how I created it. I'm going to compare e to 0. If it is equal, just to go outside, I'm done. If not, so I'm going to come this way and then come branch back. Okay? Your question now is how I can do while. It's the same idea. Here I check first. Here I check first. You can check at the end if you want to do while. So execute the iteration first and then check. Okay. So let me do it here. For example, if I want to repeat the same example like this one, but I want to do while, how it would be different. For example, I want to say do while a does not equal 0. Is that okay? So how can we do something like that in this example? Let's do it. Okay. So the idea here is I have to move this one at the end here. Makes sense? Because I have to execute the iteration first and then check later. That's how do while works, right? So that's what I'm going to do right now. So what I'm going to do here, I'm going to say here begin. Again, this can be any name. This is not a keyword, just can be any name. Okay. Anyway, and this is one iteration. So here in the very beginning, you are going to execute one iteration, at least in the very beginning. Now I'm going to check the condition. I'm going to say compare a to 0. Then I'm going to say branch if not equal. If not equal, right? If not equal, go to begin. Usually I'm going to make it long. So every time come here, I'm going to check the condition. If this condition is true, if a does not equal, so I'm going to go to the beginning again. Very good question. Why? Because listen to me. When I did while, I checked if it is equal. I checked if the condition is false. So if the condition is false, go out. Right? This is how I made it. Okay. So here I checked the condition. If this condition is false, go out. Here, the way I made it, here I'm going to check the condition, this condition. If this condition is true, go to the beginning again. Okay. Otherwise, you're going to go this way. You got what I'm saying? Again, guys, As I said before, you can use the same condition or you can use the opposite of this condition. It's okay as long as the logic, what you are doing here, is identical to the logic here. Okay. Anyway, so also I explained how can you do while loop while loops using compare and branch instructions. Also, I explained these two interesting instructions. You need them in tomorrow's lab. Branch if clear, branch if set. And I told you these two instructions are used if you have a byte and you want to check some bits in the bytes. So I want to branch if some bits in these bytes are zeros or ones. This one is going to branch for zeros. This one is going to branch for ones. Is that okay? I give you some examples. You need it tomorrow. And then I also, when I came to a full loop, I told you in case of full loop, guys. Yeah, I told you this is how we do full loops in C language. Look how we are going to do something similar to this one, guys. Okay, this is how we did in C language. I'm going to use a variable here like a counter. This one is counting. Okay, so I'm going to initialize it. So number one, I need a variable. I need a counter, a variable to use it as a counter. Number two, I have to initialize it. Number three, in every iteration, I have to increment or decrement. Number four, every time you have to check the condition. Okay, that's exactly what happens here. Okay, so I start with 0 every time I increment it by 1. So and go back and then it checks this condition. So I'm going to keep looping until I is equal to 10. Once I is equal to 10, this condition is false. We're going to go outside. This is how we made it in C language. We're going to do it the same way. We're going to do it the same way in assembly. Is that okay? However, this variable here, the counter you are using here, it can be a memory location or it can be a register. So I can use one register as a counter or use a memory location. Okay, and then so this is what I explained here, and I told you guys we are going to do full loops here by two different ways. One way I didn't explain it yet, using loop instruction, as you see here. So we have some instructions. These instructions we call them loop instruction. I'm going to explain them. Also, we can also create full loops using compare and branch instruction. So you can use compare and branch instruction, okay, to create full loops. And then I told you this one is easy. Why this one is easy? Because as I'm going to explain, one instruction is going to do several operations. One instruction. So this instruction, for example, is going to do decrement, is going to do compare, is going to do branch. Like 3 operations in one instruction. That's why it's simple, right? So, okay. However, so this is the main advantage here. Again, guys, 4 of them are going to do 4. Both of them are going to do 4. So this one is doing 4, this one is doing 4. So both of them are exactly doing the same thing. However, this one is easy because I don't need to use many instruction, because one instruction is going to do increment or decrement plus compare plus branch just in one instruction, as I'm going to explain later. This is number one. However, this one has two main problems. The first problem here is the counter has to be a register. It cannot be a memory location. Why this is a problem? Simply because we don't have too many registers. If I use one register as a counter, I will need it later. I will need it inside the body of 4. I'm gonna need it, right? So this is one. However, if you use compare and branch instruction, your counter can be register or it can be memory location. Okay, again, if it is possible, guys, if you have the choice between register and memory location, you have to go for memory location, guys. Why? Because we have too many memory locations, but registers, we don't have many registers. Is that okay? So this is a big advantage here. Another advantage here over this one is the branch is short. The jump is always short. This one doesn't have a long version. You got what I'm saying? So there is a restriction. When I explain this one, I'm gonna tell you about a trick. How can we make this one long? It is short, but I'm gonna make a trick to make it long. I'm gonna explain it. But this one only short. Here, because you are using branch instructions, And every branch instruction I explained before, you have two versions, short and long. Okay, so you can create this one long. Anyway, so I'm gonna teach. Last time I started this one, so I'm gonna repeat it again. Then I'm gonna go to the other one. So let's, here. Yeah, look here, guys. I wanna do branch instruction using. I wanna do for instruction using compare and branch instruction. Look here, guys. What I did, I made a memory location. Whatever you want to call it, I decided to call it counter. You can call it I, J, whatever name you select. And then I'm going to initialize it with 10. Okay, so I'm going to start from 10. Every iteration, I'm going to decrement by 1. So as you see right now. So, and then guys, as you see here, I'm gonna read the counter here. I'm going to put it in A. I'm going to compare to 0. I explained this one quickly in the last lecture. We're gonna compare it to 0. Actually, you don't need to write compare as I told you, because if this one is 0, so this instruction is gonna put 1 in the 0 flag. So that's why you don't need to compare. Again, if you feel this is too difficult for you, that's okay. It's always, if you put some redundant instruction and the program is working, much better than not putting this instruction, it's not working. You got what I'm saying? So anyway. So I'm totally fine. If you are confused about it, I can see here compare to 0. I'm totally fine. But just I want to tell you, keep in mind, this is redundant. I don't need it. Why? Because I want to check for equal. If you want to check for equal, so I have to look at the 0 flag. And already this load, if you are loading 0, this one is going to put 1 in the 0 flag. So it's already, what this one is going to do is already done here. So you don't need it. But anyway, okay, guys. And then here, I'm going to compare for equal. Equal means equal 0. Equal 0, right? So here, if it is equal to 0, so I'm gonna go outside. I am done. If not, so I'm gonna come here. I'm gonna decrement the counter, then go again here. This is unconditional, guys. Unconditional. So I'm gonna come here to check again, as you see here. So in every iteration, I'm gonna decrement by 1. Go back again to check. Is that 0? No, it's not 0. Okay, make another iteration. Decrement, go back to the beginning again. Is that 0? No, make another iteration until it is 0, and then I'm going to go outside. Is that okay? Someone can ask me why you started by 10. Can you start from 0 and increment? For sure, you can do that. So I can start from 0, or it can start from 1, whatever you want to do. So I can start from 0, and every time here I'm going to say increment instead of decrement. Okay, but this time here, I think I did it here. Yeah, I did it. So let's see how I do it. So here I want to use increment instead of decrement. Again, both of them are okay. So here, as you see here, I'm going to create a counter. I'm going to initialize it with number 1, right? So here in every iteration, I'm going to compare it to number 10. So I'm gonna load the counter. I'm going to compare it to number 10. If it is equal to 10, go outside. If not, come here. Increment the counter and then go back again to check again. Repeat. So what's going to happen here, guys? We're going to start from 1. So the first iteration is 1. Second iteration here, because every time I'm going to increment, it is 2. Oops. Then all the way. Okay. So, and then all the way until, for example, now it is, if it is 9, is 9, is that 9 is equal to 10? No, it's not. So I'm going to make one more iteration until it is 10. So once it is 10, when it is 9, I'm going to increment. Once it is 10, so I'm going to go outside. Is that okay? So let's see. Sometimes I'm confused. Is that if this one is going to do 10 or it's going to do 9 or 11? Sometimes I'm confused. So the easy way to do it, just to try small numbers, small number. For example, I'm going to put here, for example, 3. Let's see how it works. So in the very beginning, I'm coming, this one is 1. So I'm going to come here all the way. So this is iteration number 1. Is that right? Then increment. So go back to here. So now counter is 2, right? I'm going to compare 2 to 3, right? So is that equal? No, it's not equal. So I'm going to make a second iteration here. So this is the second one. And then I'm going to increment. So now it is 3. Is that equal to 3? Yes, go outside. Very easy, right? Just make a small number. That means based on the structure I have here, okay, if I say compared to 3, you are going to make only 2 iterations. Why? Because you start from 1. Okay. Anyway, think about it. This is very simple. If I start from 0, so that means if you put here 3, I'm going to make 3 because you start from 0. Try it. Try it using a small number. You will get what. But based on what I did right now, guys, as I told you, if I start from 1 and I put here 3, so actually I'm going to do only 2 operations, two iterations. Okay. Anyway. So now let me ask any questions so far. So here I explain how can we use compare and differential instruction to create full loops. And I didn't do anything new. I just implemented what we did in C language, because this is exactly how we made it in C language, but I just did it in assembly, right? So now let me ask you a question. If you have a loop like this one, guys, what is the maximum number of iterations you can make? Yes. That's true. That's true. That's very good. So my counter is a byte. You get what I'm saying? So the maximum I can make, maybe in a byte, 255 or 256, whatever you want to make it. For example, if you start from 0, so I can make it up to 255 or 256. Yes.
If you were really
Yes, that's what I'm gonna come to this point right now. Okay. So I just want to tell you guys, there is a limit. There is a limit on number of iterations you can make. Why there is a limit? Because your counter has a limit. It's a byte. You got what I'm saying? So I can't put more than 256. Is that okay? So your limit, I'm gonna start the count from 0, 0, 0, 0, 8 zeros until 8 ones. This is the maximum I can make. So here, guys, the maximum number of iterations I can make here 256 because I'm using a counter a byte. Let me ask you a question. What if I want to make more iterations? I want to make 300 iterations, 400, 600 iterations. What can I do? A word. So now your counter here, instead of using a byte, I can use a word counter. Is that okay? But you have to make several changes here. For example, you cannot use register A for sure. For example, I'm going to use register D, load D, for example. Here I'm going to say CBT, compare D, okay? And then also here, I can't use this increment. This is very tricky, and I made it very clear, guys. This increment is used for a byte, but this is a word, okay? So again, the way, if you want to increment a byte, as I explained to you before, you have to add 1. So I'm going to say load D, counter, and then you have to add 1, add D and 1, and then you have to store D to counter. This is the only way, okay? And then I'm going to do this way. By this way, if you want to use a word, I'm going to repeat the same question again. If you want to use a word, is there a limit on how many iterations you can make? Always there is a limit, guys. Always there is a limit. Yes, there is a limit. So what is the limit? Yeah, tell me. Yeah, for a word, the limit is the limit for a word, right? So in case of a word, it's 65,536. This is the limit. I cannot make more than that because I'm going to count from 16.0 until 16 ones. This is my limit, okay? So I cannot make iterations more than that. Is that okay? Let me, yes. No, I'm going to come to this point right now, okay? So now the question is that, what if I want to make more than that, more than 65? For example, I want to make 1 billion, or 1 million, for example. For sure, there are many ideas, but maybe the easy way we can do nested loops. That's what I'm going to experiment now. So the easy way we can do nested for or nested loops. What do you mean by nested? I mean 4 inside 4. Okay. For example, here, if I want to do 1 million, if I do 1 million, for example, so I can make 1 loop here for 1,000. Using a word counter, then inner and outer loop for another 1,000. Okay, if you do that, so this code is going to be repeated 1 million times. Is that okay? Or Actually, there are several ideas. So I can here use a byte counter to make it only 100. Is that okay? But if this is the case, how many I need it here? 100,000, or I need only 10,000, right? Because 10,000 times 100 should be a million, right? 10,000, I can make it using word counter. So in this case, I'm going to use byte counter here, and then here in the outside, I'm going to use word counter. Okay, guys? Any questions? Okay. So now what I did, I explained how can you use compare and branching structure to create for loops. That's what number one. Number two, I explained that there is a limit on how many iterations you can make, right? And this limit related to the counter. If your counter is a byte, there is a limit on how much you can count, okay, or how many you can count in a byte. If it is a word, yes, I can make more iteration if it is a word, okay. So now, what if I want to make like a very long number, 1 million, for example? Okay, so in this case, the idea of nested loops is very interesting. Any questions? Okay. So now I want to explain something related to arrays. Look here, guys. If I have an array, and this array has 20 elements, I have an array, and this array has 20 elements. Is that okay, guys? As you know from what you learned before in C language, if I want to scan this array, if I want to read the elements, if I want to scan the array, so I have to make for loop for 20 times. Is that okay? That's how you make it. So I have to loop 20 times, where in every iteration you are gonna work on one element in every iteration. You remember when you did something like array I, bracket this way I. So where I in the first iteration I is 0, so you are gonna work on element 0. Okay, then I is 1, you are gonna work on element 1, and so on. That's what you did before. Is that okay, guys? Okay. Here in assembly, if I have the same situation, what I can do? Okay, number one, you can do the same thing. If I have an array, this array has 20 elements. So in this case, I'm gonna make a for loop like this one here, guys. And then I'm gonna here put 20 in order to loop 20 times. Okay. However, listen to me. Okay. So now, but we don't have something like a square bracket I. We don't have this one. We don't have square bracket I, similar to C language. Yes, we don't have this one. However, as I explained before, we have 0, x. X is a pointer. You have to initialize x. Every iteration, you have to increment x. And then I'm going to read the location pointed by x. That's exactly what we are going to do now. So if I have an array, guys, if I have an array this way, okay? So in the very beginning, you have to initialize x with the beginning address of this array. Is that okay? So now, x is here. So in the first iteration, I'm going to read the location pointed by x. So I'm going to read this element. How can you read the location pointed by x? Very easy. You can say load accumulator A 0, x, as we did before. So by this way, I'm going to read the location pointed by x. Is that okay? Every iteration I have to increment x. So that next iteration, so every time you have to increment x. Is that okay? This is how we will do it. Is that okay? So this is one way to do it. This is one way to do it. So I can make for loops. I can make for loop something like this one. I'm going to loop 20 times. Here in the very beginning, I'm going to initialize x. So let me give you example how we can do it. For example, I have array. This array, I'm going to call it like any name, like for example, ARR, for example. I'm going to say dc.b 2375, whatever. So this is an array. And then, as I told you, before you go inside the for loop, you have to initialize x. X has to point at the very beginning, address. How can you do that? I said it before. You have to say here in the beginning, I have to say load x hashtag, okay, ARR. If you do that, so I'm gonna the beginning address, I'm gonna store it in x. This is how you initialize the pointer. Is that okay? And then here, every iteration, I'm gonna read 0, x. For example, I'm gonna say load A 0, x. in every iteration. Is that okay? At the very end, I have to say increment x. Is that okay, guys? Very easy. So for example, I have an array. This array has 20 elements. So I have to make for loop 20 times. In the very beginning, initialize x. Every iteration, you have to increment x. Is that okay? Any questions? Yes. Sorry, say it again. I skipped what? Yeah. You can do that. So for example, I can say, instead of you, this is just a compact. So instead of using 2 instruction, I can say 1 comma x, and then I put plus here. That's what you mean? Yes, because this is a compact version. Okay, both are okay. What I'm saying? Yes. Any question, guys? Okay, I'm gonna tell you a smarter idea right now. This one is okay, but I'm gonna tell you something smarter. Why what you are gonna explain is smarter? I'm gonna tell you why. Because here I need 2 things. I need pointer and I need a counter. I need 2 things, pointer and counter. I can make it smarter, and I'm gonna use the pointer as a counter as well. So now I need 2 things here, guys. I need counter and I need pointer. So I have to use 2 things, right? Now, if can I only use a pointer as a counter as well? So this will be a very smart idea. So I'm gonna use, that's what I'm gonna show. How can you make it? And I recommend to do it because this is gonna make programming much easier. You understand what I'm saying? So what I'm saying right now, instead of you using 2 different things, one to count how many iterations we have, the other one is a pointer. I'm going to use the only pointer. And then I'm going to show you how I'm going to use the pointer as a counter, right? As well. So I'm going to use only one thing. So I'm going to show here one program. And this is very good idea. I recommend to do it in case of arrays, if you want to read an array. So let me show you here. Yeah, look, for example, here, guys. I have an array. This array should have 5 elements. So this is an array. This is the name. Again, you can put any name. So this is the name of the array. This array has 5 elements. 1, 2, 3, 4, 5 elements. Is that okay? And then, as I told you, you have to initialize the array pointer in the very, very beginning. So what is very important, guys, what this instruction is going to do, this instruction is going to store the beginning address of x, the beginning address of this array. So now x is pointing at the first element. Are you okay with that? Always we are going to do that. And then the loop is here. This is before you go to the loop. The loop is here. Before you go to the loop, you have to initialize the pointer. Is that okay? Okay. Now look what I'm going to do. Forget what I'm going to do here right now. I just want to focus on, forget this part. I just want to focus on how we are going to create for loop without a counter, only with a pointer. And this is a good idea. Yeah, it's a good idea. Okay. So I'm going to tell you how. Look here, guys, what I did. As you see here, this is a for loop. This part is a for loop from here to here. Okay. So let's see what I did. After you do every iteration, I'm going to increment x. Okay, we have to do that. So every time you have to increment x. Okay. So that next time, I'm going to work on a different element. That's true. Also, look here. I'm going to compare because, look here, guys. What is the address of this element? It's array. What is the address of this one? It is array plus 1. What is the address of this one? Array plus 2. What is the address of this one? Array plus 3. What is the address of this one? Array plus 4. And then once I finish this one, I'm going to increment x. So I should be here. So what I'm going to say, every iteration, I'm going to compare the address in x. I'm going to compare it to this value. As long as it is less than this value, that means I didn't finish 5 iterations yet. Very interesting idea. So here I'm going to use x as a pointer. Also, I'm going to use it as a counter as well. Very interesting idea. Make programming easier, right? So what I did here, guys, every iteration, I'm going to compare x to the beginning address plus number of elements, which is 5. So I'm going to say what I'm going to say. I'm going to start from here. Every iteration, I'm going to compare with this address. Once I come to this address, that means I already finished 5 iterations. Okay. What if it is 20 iterations? Very trivial. All what you have to do, you have to put here 20. What if it is 30 iteration? I will put here 30 and so on. Is that okay, guys? Someone can ask me, okay, wait a second, I'm really confused. Can you do something like that? Is it, you told us we don't have addition here. You told us we don't have addition. Can anyone have answer to this? How use addition here? Assembly doesn't have addition. I'm using plus. I don't use this operator to do addition. You understand what I'm saying? We don't use this operator to do addition. If you want to do addition, you have to use one of the instructions. So how you make it this way? Anyone has a justification why I made this way? Guys, you know what's going to happen? This is not assembly instruction. This is not for the microcontroller. This is for the code warrior, for the assembler. So what's going to happen is that the assembler is going to replace this one by the address. So I just use the English name array. If array starts from 1000, so what's going to happen? Code warrior is going to replace it by 1000. Same thing here, guys. Same thing here. What's going to happen? Code warrior is going to replace this one by 1005. That's it. Any questions? Very important, this one. Okay, guys? Make programming much easier. Yes. So you see that here?
As the programmer who knows everything about the code, we just put 1005.
You can, however, why you bother yourself to calculate it? Because sometimes it's easy. For example, if you have org here 1000, right? So I know this one is going to start from 1000. You got what I'm saying? However, if you have here 20 variables, 15 arrays, are you going to count what is the beginning address? You understand what I'm saying? So if you know what is the exact number, you can put the exact number. But why you bother yourself? You just put it there and the code warrior is going to do it for you. You understand what I'm saying? Sometimes, yeah, it is easy. You can just put 1000, 1005. Yes, the answer is yes. However, in many cases, it's not easy, especially if you have too many here after org, you have too many variables. You have to count. Yes.
Is there access to the last?
Say it again, you have access to the last
Element.
What you mean by you have access? What this means? Yes, you can read. You can. This just man. This is just a location in the memory. If you tell the microcontroller, give me this location. Yes, it's gonna give it to you. This is a good point. Maybe I'm gonna say something here. Maybe I was able to understand you, or may not. But so let me explain something here. In C language, if you have like five element array, if you say I wanna read location 0, you have to stop at location 4, right? From 0 to 4, right? That's it. If I say location number 7, I think you are gonna receive error because you don't have location 7. Is that okay? Here, this is 2 level. If you say I wanna read the location array plus 10, it's gonna read it for you. Yes, it's not part of the array. It's your mistake. It's not the mistake of the hardware. It's your mistake, right? No one will correct you. So yeah, it's because this is very low level. And yeah, maybe the compiler in C language, yeah, they can catch things like this one, but here no. Anyway, you got the idea here, guys. Very, very interesting. I love it. I love it simply because this can make programming very simple. Instead of using counter and pointer, I can just use only pointer, right? Very easy. And okay, so now I want to explain this example here. And this example, guys, I'm telling you, I have write a program to count the number of elements that are divisible by 4. You are going to do something like that in the lab tomorrow in an array of 5 elements. Is that okay? So all what you have to do, guys, again, this array has 5 elements. So I have to read one by one element. So X is here. I'm going to read this element. I'm going to check is this element divisible by 4 or not. If it is divisible by 4, I'm going to increment the counter. If not, okay, so I'm not going to do anything. Then I'm going to go to next iteration. I'm going to repeat again. I'm going to get this element. I'm going to check is this element divisible by 4 or not. Okay, that's exactly what I'm going to do right now. So, and as I told you last time, if you want to check if the element divisible by 4 or not, there are different ways. maybe the difficult way, you can divide by 4. If the remainder is 0, that means it is divisible by 4, right? This is the difficult way. The easy way, you can just check the first 2 bits. If the first 2 bits are 0s, so this number is divisible by 4. Why? Because this one is 4, as you see here. This one is 4, 8, 16, 32, and so on. So 4 is a factor. So if you add them together, 4 plus 8 plus 16. So as you can see, 4 is a factor. So it's going to be divisible by 4. Okay, guys? So, and that's what I'm going to do right now. And I think that's what you are going to need tomorrow. So let's see how I make it. Number 1, look here, guys. Number 1, this is an array. In this array, we have five elements. Is that okay? So here I have to scan the whole array. In this problem, I have to scan the whole array. That means I have to loop 5 times. I have to loop 5 times. Yes. And I already did it this way. So if you look, as I explained, so this is the pointer, and we are going to loop here. This is the body of 4. This is the body of 4. So here we are going to loop 5 times. Every time you are going to increment x. Is that okay? This part is okay. And this is the body of 4. I'm going to tell you what we're going to write here in the body of 4. In every iteration, x is pointing at one element. Okay, guys? So what should I do here? Look, it's very important because that's what you are going to do tomorrow, something like that. Look what I'm going to say. I want to check if these 2 elements, are zeros. Both of them are zeros. Is that okay? So I'm going to say branch if clear 0, x. So this is the location. This is the address. So the byte at this memory location, okay? And this is the mask, as I explained last time. The mask is 11000. So I want to check these 2 bits, the first 2 bits, right? So I want to check the first 2 bits in this byte. And if they are clear, if they are zeros, please go to yes. Yes is here. And when I come to yes here, I'm going to increment a counter. If the branch is not taken and I came this way, so I have to skip the counter here. Okay. So what's going to happen, guys? In case of 0, 0, this branch is going to be taken. In any other case, very important. So here, branch if clear. Here I mark, or I decide which 2 bits you wanna check. If these 2 bits are 0, 0, so the branch will be taken to here. If not, if anything else, like as you see here, 0, 1, 1, 0, 1, 1, anything else, the branch is not going to be taken. What do you mean the branch is not going to be taken? That means I'm going to come this way. So we're going to come this way in this case. We're going to come to here, to yes here, in case of 0, 0. Is that okay? So if I come this way, so I have to skip the count here. So I'm gonna only increment the count, because I want to count how many elements are divisible by 4. Every time I find element divisible by 4, I'm going to increment the count. Okay, guys, any questions? Okay, I'm going to do something very little thing, and you can tell me very little. I'm going to change just 1 bit. The program will be completely different. Okay, so if I change the mask here for 1, 1, I'm going to make it 0, 1. Can someone tell me what this program is doing? Did you see what I did? Instead of 1, 1, I'm going to make it 1, only 1, 0, 1. What is program? Yes. Yes. So here I'm going to count how many elements have 0 here. I want to count how many elements have 0 here, right? And what this means? It means I'm going to count how many even elements I have. Because that's what you need tomorrow. Tomorrow I'm going to ask you to count how many odd numbers you have. Because if you have 0 here, that means this number is even, right? So if you just make a small change this one, so this program will do something completely different. It's going to count how many even numbers you have. Is that okay? Okay, so what if I put the 1 here? So I'm going to put here 1 here. So I want to check this bit. Okay, so what's going to happen here? You want to count how many numbers here have 0 here? How many numbers have 0 here? How many elements have 0 here? Okay, which means how many positive or 0 numbers we have, right? So I'm going to count the number of positive or 0 elements. Make sense? Because the last bit here, we are going to change this bit. This bit should be 0. That means this element is 0 or positive. Any questions? Okay, let's have one more program, because also you need it tomorrow and tomorrow's lab. Very simple program. Look here, guys. I have array. I have an array. Is that okay? I wanna find the minimum element in the array. I wanna find the minimum element of the array. How we can do it? I'm gonna tell you how I'm gonna do it. Assume this is the array. One element, and so on. Is that okay? So the way I'm gonna do it, guys, is I'm gonna have a variable. This is a variable. This variable, I'm gonna call it minimum value, whatever you call it. So I have a variable here. I'm gonna take the first element, I'm gonna put it here in the variable, right? Then I'm gonna start scanning from the second element, for element number, from the second one. So what I'm gonna do in every iteration is I'm gonna compare this element to this element. Okay? If this element is smaller than this one, I'm gonna take this one, put it here. If not, so I'm gonna put the next one. So I'm gonna compare what I have here with this one. If this one is smaller, I'm gonna put it here. If I continue this way until the end, so what I have here is actually the minimum value, right? That's exactly what I'm gonna do right now. So what I'm gonna do right now, as you see here, guys, I wanna write a program to find the minimum element in an array of 20 elements and to store it in a variable with whatever the name minimum value. The array starts from address 2000. That's what I'm telling you. So the array should start from location 2000, and this array has 20 elements. So the idea here, as I told you guys, I can take the first element here, I can put it in this variable. This is my hand. So this variable is my hand here, okay? So I'm gonna take this one, I'm gonna put it here in the minimum value. And then I have to scan the array from here until the end. In every iteration, what I'm gonna do, I'm gonna compare this number with this element, right? If the element is smaller, so I'm gonna put it here because I'm looking for the smaller, okay? Once you finish scanning to the end, so what you have here is the minimum value. So that's exactly what I'm saying. So number one, let me clear this one, then you can. So number one, you have to read this value, you have to put it here in minimum value. Number two, you have to scan the array starting from 2001 until the end, right? Now, in every iteration, I'm going to compare this variable to the element, to this element. If the element is greater, do nothing. If the element is less, please store this element in the minimum value. Is that okay? This is the main idea. Even if you do it in C language, you are gonna use the same logic, same thing in any other programming language. So now let's see how can we do it in assembly. How can we do this in assembly? Okay. Number one, again, I need full loop. I have to do full loop. And you told us it's a smarter idea to use a pointer as a counter as well. Yes, that's what I'm gonna do. Right. So see what I did here. Before I show you, first I want to show you. First, I want to show you the full loop. So this is the body. So don't look at this part for now. Yeah, just this is the body. Forget it. This is the body of 4. First, I want to explain how I created the full loop. Okay. So let's see what I did here. Okay. So as you see here, guys, number one, I have to initialize X with 2001. Because I'm going to start from the second element, not from the first element. So I have to initialize it. By the way, if you start from the first element, it's not going to make a difference because you are going to compare the first element to the first element. I think tomorrow it's going to be easier to do this way. You understand what I'm saying? So here, let me say it again. If you want to start from the, I'm going to take the first element, put it here and compare starting from the first element, it's still okay, right? But just you are going to do one comparison extra. You don't need it, right? Because I'm gonna compare the first to the first, right? I think tomorrow in the lab tomorrow is going to be easier to do this way. Anyway, so let me see. So here, guys, number one, I have to initialize X with the second element. So we started from 2000. So I have to start from 2001. I made a mistake here. you have to put hashtag here, right? Because I want to store the address. Make sense? Okay, so I want to store the address. So now I'm going to initialize X before I go to the for loop. Let's see how you created the for loop before we look at the body of the for loop. The way you create it, as you see here, guys, in every iteration, I increment X in every iteration. Then I'm going to compare it to array plus 20. I'm going to compare it to the last location. If not equal, go back. So I'm going to keep looping 19 times. Okay, are you okay with the for loop, guys, before I move forward? So this is how I created the for loop. So this part, yeah, this part here, this is the initialization of X. And this is here, this is how I made the for loop. Is that okay? Okay, now forget the for loop. Let's talk about what should I write. What should I write in every iteration? Very simple. What I'm going to do in every iteration is I'm going to compare this element 0, x. I'm going to compare 0, x. I'm going to compare it to minimum value. I'm going to compare. If this one is smaller than this one, please come here. Otherwise, do nothing. That's what I want to do. That's exactly what I did. So what I did here, guys, I want to compare minimum value to 0, x. I don't have one instruction to do that. That's why I'm going to read this one. I'm going to put it in register A. Then I'm going to compare register A to 0, x. Is that okay? And then I'm going to say branch if less or equal. If it is less or equal, please skip, come to here. So that means if minimum value is less or equal than element, please skip here. Yeah, so skip this one. Otherwise, what I have to do, guys, I'm gonna move this element 0, x. I'm gonna move it to minimum value. Can you see here? So it's gonna come here. If minimum value is less, it's gonna come here. If the element is less than minimum value. Okay. So here at this part, I'm gonna compare minimum value to 0, x. Then I'm gonna say if it is less than or equal. So if the minimum value is less, which is stored in A, is less than or equal this one. Okay. So please skip this part. Otherwise, if this one is bigger than this one, otherwise I'm gonna take this element, put it in minimum value. Any questions? Okay, let me ask you 2 questions. First question is, this program should calculate the minimum value. If I wanna, sorry, not calculate, this program should find the minimum value or minimum element. If I wanna make it, I wanna find the maximum value, the biggest number, biggest element. What would I change here? You understand what I'm saying? So I wanna find the maximum value instead of the minimum value. What would I change here? Minor change. I would change this one because here I'm gonna skip when the element is less than or equal. Now I'm gonna make it greater than. Make sense? So if I say if this one is greater, if the minimum value is greater, so skip here. If not, if the element is greater, so I'm gonna put it here. You got it? Here, if you change here instead of less or equal, I'm gonna make it greater. Okay, so if the minimum value is greater, don't do anything. Okay, if the element is greater, I'm gonna come here to take the element, put it here. Is that okay? So just by changing this one, instead of less, I'm gonna make it greater. Any questions? Very important, another very important thing, because you need it tomorrow, is this array for signed numbers or unsigned numbers. Are you doing signed number or unsigned numbers? Who can tell you? Who can tell you here if signed or unsigned? Who? Yes. Hmm? No, flags are flags. No. Yeah, I should decide in the beginning, but how I can know? I already decided. I already decided. I'm asking you, which instruction here can tell you this one is gonna do signed, is gonna do signed or unsigned? No, not compare is gonna do subtraction, so it doesn't matter. The only instruction here, if you look at all these instructions, the only instructions that can tell you if I'm doing signed or unsigned is range, not compare. Compare just doing subtraction. Why? Because I told you before, we have two types of branches. Branch for signed, branch for unsigned. You got what I'm saying? So this one, LE. LE less than or equal. I don't remember. Less than or equal, this one should be signed or unsigned. Can anybody remember? Yeah, here. Look here, guys. I told you. Yeah, LE is here. So this is for signed numbers. Right? So if you want to make this program, if you want to make this program for unsigned numbers, I would use this one, BLS, instead of BLE. Very interesting. Just one letter. If you put E, so it's going to be signed. If you put instead of E, you put S to make it this one, so it's going to be unsigned. Okay. Tomorrow, the array you have, I told you this is for signed numbers. Signed numbers. So please don't use anything from here. You have to use these ones. Okay, because this is for signed numbers. That okay, guys? Any questions? Okay. So anyway, so very interesting. I told you here. I told you how can you change this program from minimum to maximum. Also, I explain how can you make this program for signed number or unsigned number. As you said, this is something I have to decide in the very beginning. Yes, sure. I have to decide in the very beginning, and then after I decide, I have to use a correct instruction. So here, because this is a signed number, I use BLE, right? Because this is for signed numbers. If this is unsigned number, I would use BLS. Is that okay? One more thing I want to tell you guys here. Here, in this, I told you about this idea, guys. How can you use? I told you about this idea. There is something very simple, but I know I wanna say it because it's still some students confused when I explain something on bytes, and then we move to words. Some students are confused. Okay, it is simple, guys. Okay, so this example for array of bytes. This example for array of bytes. Okay, if this one array of words, what would it change here in this example? What would it change? Number one, I'm talking about the full loop. Number one, if every iteration I have to increment by 2. Makes sense? Not increment by 1. So yes, so I have to do here increment twice. I have to increment by 2. Is that okay? I think tomorrow you are going to also need something like that because you have array of words. So if it is array of words, so every time you have to increment by 2. Is that okay? This is number one. Number two, if this is array of words, I would not say here 5. I would not say array plus 5. I would say array plus what? 10. That's correct. Why? Because from here to here we have 10. Okay, because every element is going to take 2 locations. That's it. Okay. Everything else you have to use, for example, here, everything. So every element here you are going to read 2. You are going to read 2 bytes. Okay. Any questions? Okay. So maybe I want to spend some time. I told you before, guys. Tomorrow's lab is somehow I don't want to use the word difficult. Nothing is difficult, but it needs some time. Tomorrow's lab, it's long. Maybe comparing to the previous lab, this one is longer, but I think it's very important. Very please, if you want to do well in this course, this topic compare and differential instructions is very important topic. So you have to do your best. Try to give it time to understand. Please don't copy from others. If you just copy and you don't learn, you are gonna face you are gonna have a lot of problems in this course because all the time we are gonna do compare and differential all the time. So it's very important. And tomorrow's lab we are gonna have a big program about compare and differential. So that's why I want to give you some help now to make it easy for you when you do it. Okay. So in tomorrow's lab, guys, I'm telling you, we have an array. Okay, whatever the name of the array, we have array of bytes. Okay, and this array, it has what we call a delimiter. A delimiter. So what you mean by delimiter, and why you are using it? Delimiter. What you mean by delimiter? I'm gonna tell you. Look here, guys. There are two cases. One case, I tell you, I have array, and this array has 20 elements, 30 elements, right? So fixed number of elements. So all what you have, if it is 20 elements, all what you have to do, I have to loop 50 times. If it is 50, I have to loop 50. If it is 20 elements, I'm gonna loop 20 times, and that's it. Is that okay? This is, sometimes we do that. Sometimes I'm giving you array, and I'm telling you this array, it has 100 elements. So you have to loop 100 times. Is that okay? Sometimes I'm gonna do it in a different way. I'm gonna tell you, you have an array. How long is this array? I don't know. Okay. Maybe it is 2, maybe 3, maybe 4, maybe 5, maybe 20. Okay. However, there is a special number. I'm going to use it to tell you this is the end of the array. That's what we call a delimiter. Okay. So the delimiter here is a special number. This is special number. I'm going to use it to tell you this is the end of the array. You got what I'm saying? So that means this number should not be repeated here. Okay. This is array of bytes. This is array of bytes. And as you know, every byte should have a value between negative 128 until positive 127. This is what you can store in a byte, right? However, I took this one, and then I'm going to use it as a delimiter. And every element here should be between negative 127 and positive 127. So number one, I have to select a number. I have to make sure this number is not gonna have in here in the array, right? Because this is the delimiter. Once you find this number, this is the end of the array. Is that okay? Okay. So in this case, listen to me. In this case, how many times I have to loop? In this case, you have to use a while loop. You have to loop until you find this delimiter. Okay? You have to loop until you find. So here you cannot use full loop because I don't know how long is the array. I don't know. You got what I'm saying? So that's what we are going to do tomorrow. So what you are going to do tomorrow, guys, is the following. You have to use while loop. While you have to do while the element is not negative 128, you have to keep looping. Tomorrow you have to make only one loop. Okay? In every iteration, you have to work on one element in the array. How can you do that? As follows. Look here, guys. X is here. X is pointing at the first location in the array. I'm going to read the element. I'm going to ask you that. Are you negative 128? No. I'm going to do one iteration. Then increment X. Get this guy from here. Are you negative 128? No. Do one iteration. So I have to keep doing this until when I come to 1, read this 1. Are you negative 128? Yes. Go out. You should not do operation with this element because it's not an element. The delimiter is not an element. So you should not go inside the loop of while in this case. Is that okay? Okay, you understand what I'm saying? So how can you do that? Very trivial. That's what I'm trying to help you, because tomorrow lab is very important. So that's what you have to do. Number one, guys, is exactly what I explained right now. Number one, you have to initialize X with the beginning address of the array. This is number one. Number two, this is how I made while. Here, this is how I made while. So as you see here, guys, I'm gonna read element pointed by X. I'm gonna compare this one to negative 128. You don't need to bother yourself to convert it to binary or convert it to hexadecimal. No, leave it decimal. It's okay. Just save your time, right? Code Warrior is gonna take care of it. Okay. So anyway, so now I'm gonna compare it to negative 128. I'm gonna say, if you are equal, please done, leave. Very trivial, very easy. Look what I'm saying. So I'm gonna initialize X, okay, and then if it is equal negative 120, leave. Otherwise, if it's not 128, so I'm gonna come this way. Every iteration I have to increment X, and then I have to long branch to begin. and I have to put begin here. Not here, guys, because I'm not gonna reinitialize every iteration. Be careful. I'm not gonna you initialize before you go to the inside the while loop. So every time I'm gonna come here, increment X, and then come back to here to check again. That easy? That's what you have to do tomorrow. Okay. In every iteration, you are gonna work only in one element pointed by X. In every iteration. Is that okay? Then I give you a list of things you have to do. So now all what you have to do now, I finished one part of the lab. So now you have to fill up the code here. Okay. So I give you a list of things you have to do. Okay. On every iteration. You have to do for every iteration. Sorry, for every element in every iteration. Again, I'm going to say it again. In every iteration, we are going to work on one element. Okay. So let's see. For example, I'm just giving you one example. So this is the body of Y. Here, you have to do several things here because I asked you to do several things in this lab. I'm going to solve only one, and then I'm going to leave the rest to you. So, for example, I want to count the number of positive elements. The number of positive elements. Yes, I can do something like that. Now, I'm going to compare A because A is the element I'm storing it in A, right? If the element is not in A, I have to say load A 0, X because X is going to point on the current element. Okay. So anyway, so I'm going to compare A to 0. Then I'm going to say if it is less or equal, please go to next here. If not, come here to increment a counter. I'm going to call this counter positive count. You are gonna do several ones like this one because I asked it, as far as I remember, I asked you to count how many numbers are odd or even, as far as I remember, how many numbers are zeros, how many numbers are positive, something like that. So every time the element is in A, I'm gonna compare it, for example, to 0 here, and then I'm gonna say if in this case, if it is less than or equal 0, so I'm gonna come here. Because positive, I'm not going to consider 0. Again, it's okay. If you want to consider 0 positive, that's okay. It's not a big deal. You are not, this is not a math course anyway. So, but usually here, what I did here, it is equal, this will equal. That means I'm not going to here count 0 as a positive number. Okay. So I need to make one loop because in the past, I found some students did several loops. I don't know why. I asked you one loop. In every iteration, you are going to work on one element. So I give you a list of things you have to do. You have to do all these things in every iteration for every element. Is that okay? The other thing here is so someone can ask me, okay, you told us about the idea of delimiter. Delimiter is a special number to tell this is the end of the array. Is that okay? So why this is a good idea? Why it's a good idea? Why you just don't tell me this array has 20 or has 30 or has 40 or whatever? Okay, I'm gonna tell you why it's a good idea, and that's what we are gonna do in chapter 4. Okay, chapter 3. Okay, it's a good idea, guys, because if this array has 20 elements, okay, I don't need to change the code. I can just, the code is going to work. If I put the delimiter after 5 elements, if your array is 5, so regardless how big is your array, okay, you're going to use the same code. You're not going to change the code, right? Because I don't have here, because I don't, if you make, for example, 20 iteration, so you can only use the code if it is 20. You got what I'm saying? So and sometimes it's just easier than, okay, so if I don't use a delimiter, I can, how I can do it as something else. Okay, you have to give me n. N is how big is your array. So you have to give me two things. You have to give me the array and how many elements. Okay, so yes, you can do that. Just give me how many elements and give me the array, and then I'm gonna run the code based on that. Okay, or let's make it smarter. Just don't tell me how many elements. Just put the delimiter and I will figure it out. I will figure how big is this array. You got what I'm saying? Sometimes it's bad to count how many elements. For example, that's what we are gonna do in chapter, yeah, here. That's what we are gonna do in chapter chapter 3, guys. In chapter 3, I want to display. If you want to display a message here on the LCD, there is a function we are going to use. This function is called put string to LCD. So I'm going to teach you this function. In this case, also we're going to use the idea of the delimiter as well. We're going to use the idea of the delimiter. Okay. So here, when you have a message, I'm going to ask you to put 0 here at the end, so that this function is gonna start from the beginning. It's gonna display until it finds 0. Once it finds the 0, so 0 in this case is the delimiter. You understand what I'm saying? So why it's interesting idea now? Because it's just easy. I don't need to count how many. So if I want to display this message, if you don't use a delimiter, you have to count 1, 2, 3, 4, 5. I'm gonna tell this function, you have to display 5. You know what I'm saying? Here I have to count how many, but for sure it's not a good idea. It's a better if you just use a delimiter. So the delimiter is a special element. This special element should tell the function this is the end of the array, right? To make it just easy. Is that okay? And you have to be smart. The number you have to use for a delimiter, the number you have to use for a delimiter, you have to make sure it's not going to be repeated here. Because if this number happens here, so once it finds the delimiter, it's going to stop here. You got what I'm saying? That's why in this case I selected number 0, because there is no character that has ASCII of 0. You remember when I told you, when you make it this way, this one is going to be stored array of ASCII. So I'm going to see ASCII of H, ASCII of O, ASCII of W, ASCII of space, and so on. That's why I'm using number 0, because I'm sure there is no character. It's not going to happen that there is a character that ASCII of 0. Is that okay? If you use something else, it may happen that the character is going to be repeated here. It shouldn't happen. Okay. Any questions? One more thing confuses students here in this lab, in tomorrow lab. In tomorrow lab, I'm going to give you one information. Some students don't understand why you give us this information. I'm going to tell you why. So in tomorrow's lab, I told you well, I'm going to use a delimiter, and the number of elements are always less than 255. Yes, this array can have different lengths. The size can be different. However, it's not going to exceed 255, maximum 255. You got what I'm saying? So I'm going to give you this information in the lab. So why I give this information to you? The reason is because one of the things you have to do tomorrow, you have to count how many elements we have. You have to count how many elements, right? So because I'm sure the number of elements are not going to exceed 255. So if I want to use a counter to count how many elements, byte is enough. That's why I'm giving you this information. So I'm giving you this information so that your count, if you want to count how many elements, so you have to use a byte variable, because byte should be enough to store 255. You got what I'm saying? Because one of the things you have to do tomorrow, you have to count. So here in every iteration, you have to say increment count. You have to tell me how many elements and how many elements we have in the array. Is that okay? Any questions? One more thing I told you is this array is signed numbers. So you have to make sure everything you are using should be for signed. If you do multiplication, has to be for sign. If you do division, has to be for sign. If you do comparison, has to be for sign. If you do extension, has to be for sign. Because I told you this array has signed numbers. Is that okay? Great. Let's have more examples here. Okay. In this example, guys, what I want to do here, I have array 1. I want to copy. One more thing for tomorrow, because before I forget it, something also maybe is gonna confuse some students. I told you guys here in the body of W, in the body of while loop, I'm gonna use X as a pointer. Is that okay? So X is gonna be a pointer. Okay, guys. So what if I want to use X? I want to do multiplication, I want to do division, and I want to use X. What can I do? You understand what I'm saying? So here in every iteration, X is a pointer, right? for sure what you have to do. Okay, guys, what you have to do, guys, is x. You have to store the value of x somewhere. For example, in a memory location, you have to store the value of x somewhere, and then you can use x. You can use x, but you have to make sure before you go back at the end here, before you increment x, before you come at the end here, you have to return this value again to x. You got what I'm saying? Is that clear? You will need it tomorrow. So what I'm saying, x, I'm going to use register x as a pointer. So x is storing an important number. I should not lose this number. Okay, but I want to do multiplication, I want to do division, or I want to do something, and I need x, or I need x for something else. Can I use it? Yes, you can use it. But the value of x, you have to store it somewhere. And what I mean by somewhere now, a memory location. Just to make a temporary memory location, store the value, the value stored in x, and then when you are done, after you finish, and now you don't want x anymore, return this value to x again before increment, so that your program can work correctly. Any questions? Very important thing. I'm gonna clarify later, but very important. For now, I told you to solve this problem. For now, I told you x, you have to store it x somewhere, and then you change x and then get it back, put it in x back. Okay, that's what I told you. Okay, what do you mean by somewhere? For now, somewhere is just any memory location. So make any temporary memory location and use it for now. However, it's not a professional way to do it. The professional way to do it, and that's what, but I'm not asking you to do it now this way, right? I want you to do it the simple way for now. Later, I'm going to explain a stack. Okay, so there's a professional way you have to do it. You have to put it in the stack. Once you need it, you can get it back from the stack. Okay, so why this one is better than what you accept? Why is this using the stack is better than just storing in a memory location? Because anyway, I'm going to explain later in this anyway, but the reason is that what if I want to store here? If it is only x, it would be easy. What if I want to store 100 bytes, 200 bytes, or something like that? It's going to be too difficult. The good thing about stack, you don't need to remember addresses. You just tell the stack, please save this number. When you need it, stack, give me this number. That's it. So you don't need to allocate memory locations. You don't need to remember where you stored it. You got what I'm saying? But anyway, for now, forget what I'm saying. But just I'm gonna clarify it later. For now, if you want to store it x in a memory location, and then use it, take it from this memory location. But you should understand what you are doing right now is not the perfect way. The perfect way, I'm gonna explain it later when I teach stack. Okay, but it should work now. Let me give you another example here. In this example, guys, I have two arrays. The size of each array is 5 elements, and I want to copy this array to this array. So I want to copy this element to here. I want to copy this element to here. I want to copy this element to here. Is that okay? So what I'm going to do, I'm going to make for loop for 5 times. For loop. Every iteration, I'm going to copy from here to here, from here to here. Okay. Also, this is something very important because you also are going to need it tomorrow as well. Okay, tomorrow is a big lab. Okay, hopefully I hope you learn it well and you enjoy. Listen to me. Now I have 2 arrays. Should I use 1 pointer or 2 pointers? Actually, because you have 2 arrays, you should use 2 pointers, right? So for example, I have a pointer here, x, as you see here, x. I'm going to use another pointer, y. So if you look at this row, and this row is like an array and array. X is here, y is here. I'm going to copy y pointed by x to the location pointed by y. Every iteration, I'm going to increment x and y. Then I'm going to copy this guy to this guy. Because that's what I want to do. I want to copy elements from one array to another. Okay, so I'm going to have 2 pointers. Okay, this pointer is here, this pointer is here. Copy from here to here. Then every iteration increment to both. Copy from here to here, and so on. Tomorrow, you need two pointers as well. Okay, so that's what I'm gonna do now. So look here, guys. I have an array. Just give me 1 second. I have an array. This is the element of the array. Here I'm gonna loop 5 times. This is the full loop, as you see here. This is the full loop. I'm gonna initialize X, I'm gonna initialize Y. 2 pointers, X and Y. This one is gonna move here, this one is gonna move here, right? Also, in every iteration, I have to increment X. In every iteration, I have to do the following. Look here, guys. Look here. I have to copy a byte pointed by X to the location pointed by Y. So I have to copy one from here, put it here. One from here, put it here. Okay. So I have to copy a byte location pointed by X to the location pointed by Y, and then I have to increment X, increment Y. Okay, because both of them are moving. Any questions? The very interesting thing now is these 3 instructions, I can do it only using 1 instruction. Very interesting. You see what I did? So here, this instruction, guys, is actually 3 instructions. This one is going to increment X, increment Y. This one is going to move from the location pointed by X, this one, to the location pointed by Y, and then increment X, increment Y. Very interesting. So 1 instruction, this one is equivalent to these 3 instructions. Any questions? Okay, again, try to do, give some time to tomorrow's lab. Okay. Something here, again, very important because it's still confusing to some students. I'm going to say it quickly. I told you, and I said many times, guys, when I say this one is used for a byte in memory. So when I say increment 0, X, what this instruction is going to do, the location pointed by X, whatever here is going to be incremented by 1. So whatever is stored is there, I'm going to add 1 to this memory location. Okay. However, when I say increment X, this one has nothing to do with memory, no memory here. This one, I'm going to increment register X. But this one, I'm going to increment the value in this location. Is that okay? Just want to make sure you understand the difference. This one is not memory. I'm incrementing register, not memory. This one, I'm going to increment a location in memory. This location pointed by X. Okay, guys? Anyway, that's very enough for today. See you tomorrow. As I told you, there is a quiz tomorrow on this section. There is a quiz tomorrow on branch and loop instruction.